the difference between all of these grains is the burn rate matters, so that they change how fast the fuel burns and how much pressure we need for the mission. So the formula for the burn rate is R equals to AP to the power of N, and then R is the burn rate, P is the pressure, chamber pressure, and A and N are empirical constants. It also depends on the regressive and burn, neutral burn, and progressive burn. So regressive burn is when the area of the burning surface decreases with time, which leads to a declining pressure. So the thrust decreases over time. For the neutral, it stays constant. So the burn rate, burning surface is constant over time. The thrust remains constant. For progressive burn rate, the surface, the burning surface area increases with time. So there's more thrust compared to regressive burn or neutral burn. End burning grain is one type of a grain configuration. You solid propellants. So in this, the propellant burns from one end towards the other. So in the propellant chamber, after ignition, it burns from one end with through, and there's oxygen that goes through with the
Hello. Hello.
Yes, we can hear you, Vinay.
Pizza.
hello.
Yes.
Yes.
Sorry, was I not audible?
Yeah, now it is clear. Can you go with this slide and burning grain?
Sorry.
Can you start from the end burning grain slide?
From the end burning grain.
Yes.
Okay. Yeah, so I was saying with the end burning grain, the propellant burns from one end of the solid propellant to the other end, basically like a candle. So the cross section area for this grain is constant. You can imagine a rectangular or cylindrical shape throughout the propellant, uh, like the first one over here. This is the cylindrical one, and it burns through. This is the area that burns.
Deepika, I think your uh, screen sharing was off.
Sorry. Okay. Is it visible now, sir?
Yeah, it is visible now.
Okay. Yeah, I was saying the first one is the end burning grain,
Okay.
where so the shaded part is the region that burns constantly. So it is a constant burning. Uh, and then yeah, and it is neutral burn. Uh, moving to the next internal port, tubular slash singular core. Uh, this is basically a cylindrical grain with a central circular port, like the hole, the one that I just showed. So for the end burning grain, there is no circular port or hole in the center. It's basically one whole cylindrical tube. But for the internal port, it has a uh, circular port or hole. Uh, burning burns radially outward, increasing the port radius. So it starts burning from the inside of this, from the center towards the outside. So the burning rate is basically progressive. It keeps increasing because the radius keeps increasing in the in the in this type of grain, in the first one. And then there is multi-port or multi-tubular ports. Uh, these have many circular ports or like holes in them. Instead of, they don't have to necessarily be in the center. I don't think I have a picture. This one on the end is kind of what it looks like. Um, yeah, this will also be a progressive burn rate because it the radius keeps growing from each port. So the burn rate keeps increasing as the radius increases. And then there's star-shaped port. Uh, this is the image on the bottom left. So with the star-grained shape, the star-grained propellant grain, the center or the hollow portion is shaped like a star. So initially it will have a larger perimeter or surface area where it burns, and as it burns inwards, the points smooth out. So the area keeps decreasing.
Okay.
Yes, sir. And then there's phenocil. Uh, so this has, I'll show you the picture before I go ahead so that it's easier to explain. I don't think I have a picture of it, but for the phenocil grain type, the the geometry is basically, it has internal ports with radial fins like spokes forming long grooves, internal fine ports inside a cylindrical grain. And then the burn rate is nearly neutral. As fins burn, the exposed area reduces or increases in a way that holds total surface area constant. And this is used for medium to large motors needing flat thrust profiles. And then there's segmented or modular grains. Uh, these grains have like uh, different segments or pieces, um, sometimes with different geometries stacked. So they are stacked together, whether it be star segment first, and then a tubular, or a tubular first and then a cylindrical, depending on how
Uh,
much
Geetika,
thrust.
again, your screen was off.
Sorry, I don't know why this keeps happening.
Yeah, now it is okay.
Okay. Um, yeah. So depending on how much thrust you want initially, So if you want more thrust in the beginning and then you want to reduce the thrust, depending on that, you choose the grain type in this stacked uh, grains. So the area behavior or the burn rate depends on the type of grains you choose in the stacks. And
Okay.
there's other shapes like the slotted or wagon wheel, uh, which have radial slots arranged like a wheel, used to tune early area and progression. This one in the middle on the bottom shows the wagon wheel, and then this is the slotted one.
Okay.
And then there's hollow end burning, the inner cavity that burns lengthwise as well as radially. This is less common because the burn rate is not, how do I say? It burns lengthwise and radially, so the burn rate is regressive. So you don't get much, or you get instant uh, thrust, and then the thrust reduces by a lot since the surface area reduces.
Okay.
Yeah, that is it. So these are the typical applications for end burning, multi-port, and star and phenocil.
Yeah.
Yes, sir.
Okay. Okay, Gitika. So I think I have mentioned you about open motor software, right?
Yes, sir.
So did you get that software now?
Sorry, sir.
Are you able to use that software?
I wasn't able to download it, sir.
So is there any issue in downloading?
Sorry.
Is there any issue in downloading open motor?
I tried downloading it, but it just didn't download.
Okay, I will directly send you the software in Google Drive. So download from it and just install it. Since it
Okay.
is open software, you don't need any crack file or anything to use that.
Okay.
Okay, in that design a different layer solid propellant.
Different layers, or like a segmented
Yeah,
one.
yes.
Okay.
Like initial I want a progression rate, then neutral, then regression.
Progressive, neutral, and regressive.
Yes,
Okay.
and the burn rate should be around 4 to 5 seconds,
Burn rate 4 to 5 seconds.
and pressure should be chamber pressure should
Pressure should
be 4.5 megapascal.
4 to 5 megapascal.
4.5 megapascal, or you can
4.5.
take in between 4 to 5 megapascal.
Okay.
Okay, and chamber length is nearly 1 meter. Combustion chamber length.
Oh.
So use different grains. Like first you can go with circular one,
Yes, yes.
circular configuration. Then phenol. Like you can divide this 1 meter chamber length into different parts. Like you can go with 5 grains, 5 solid
Oh,
propellant grains, or 4 solid propellant grains.
okay, sir.
Okay, and it should be in this form: progression, neutral, and regression.
Okay, sir.
And burn rate should be, I mean, burn time
Yeah.
should not exceed 4 to 5 seconds.
4 to 5 seconds, sir.
Yes. So I will, I just sending you now. Like I will upload it in Drive and I will send you. Okay.
Okay, sir.
Yeah. Okay. This is a next class, and if you are okay with this, you can leave this meet to Geetika. I will
Okay.
share you the link
Okay. Thank you.
directly. Yeah. Samira ma'am.
Yes, Vinay.
Yeah, you can go with Lalit.
Okay. Yes. Hi, Lalit.
Yes, ma'am. Good evening, ma'am. Namaste.
Good evening. Okay. So, what was the previous discussion we had about was about the servo motor, right? So, Vinay has
Yes, ma'am.
also
Servo
given
motor.
you a bit added about that defense of the
Yes,
servo
ma'am.
motors that you have. Correct. So,
Yes,
you
ma'am.
you can you have to give a PPT presentation. Okay, you need to prepare a
Yes,
presentation.
ma'am.
Yeah. So, can you do that? I have asked you like already. So.
यस मैम मैम मैं वो किया हूँ मैम आप
Mhm.
थोड़ा चेक कर लीजिए कैसा है मैम मैं आपको स्क्रीन शेयर कर दूँ
Yes, please. You can just go ahead and share screen.
ओके मैम मैम आई कांट डू इट मैम इज इट विजिबल
No, it is not.
ओके मैम मैम नाउ
Yes.
yes ma'am ma'am so here I did a presentation about servo motor and also presentation so ma'am आज मैम एडिटिंग में गलती होगी सॉरी मैम मैम इट्स अबाउट फर्स्ट आई रोट अबाउट what is servo motor then ma'am I write it about as you said ma'am servo motor diagram uh, then ma'am I did about working of servo motor and its diagram then ma'am step by step explanation of it then about AC servo motor and DC servo motor, and I also did diagram of it of AC and DC servo motor diagram. Then, ma'am, in seventh there is servo motor principle of working with diagram as you said. Then, ma'am, uh, I have about
Lalit, can you
some
share
things
me this
like
presentation in the WhatsApp? I'll share my screen here.
okay, I'm sure. Then it
Yeah,
will be very
just
comfortable.
yeah.
Mhm. मैम इसको सेंड कैसे करूँ मैम कॉपी लिंक करके भेजूँ क्या लिंक
नहीं नहीं आपका प्रेजेंटेशन आप शेयर व्हाट्सएप पे कर दो मेरे को.
मेरा फोन ही रहा
हाँ शेयर शेयर
हम
नॉट सेव
ट्राई
शेयर शेयर नॉट सेव हाँ शेयर
ये
या
लिंक आ रहा है मैं
स्क्रॉल
बोल
डाउन
के भेज
हाँ स्क्रॉल डाउन यू गेट व्हाट्सएप एंड ऑल. ओके लिंक ही भेज दो आई विल जस्ट सेंड.
ओके मैम आ जाएगा तो नो प्रॉब्लम
Just send me one.